number 21, we're going to set up our own equation. It's talking about a box. It says the height of the box is 5 inches, so if you know how to draw on those little box setups, I'll draw a picture to figure on. We're looking at a box. It says the height is 5 inches, so it's 5 inches tall. The length is 3 more than the width. There's 3 dimensions, length, width, and height in your box. So the length is 3 more than whatever this width is. So you could call the width unknown x, and then the length of the box would be that plus 3. And you know, it doesn't really matter which way you turn this thing, which dimension you called what, because they're all 3 going to just be multiplied together. The volume of a box is length times width times height, the 3 dimensions multiplied. So once we get this set up, it tells us that the volume of this box is 350 cubic inches. And then the length, we let that be x plus 3. The width is the unknown x, and the height was given to us straight out as 5. It looks kind of funny to us in this order, so you might feel more comfortable rearranging this and saying 5x times x plus 3. But do you see it's equivalent? You can rearrange multiplication. And then normally we would just go through that and distribute to solve, but an optional step is this multiplied 5, we could divide that out and make our problem a little easier. So dividing out the 5, perfectly acceptable to do that. That divides into that evenly 70 times. All right, now I'm going to distribute the x. So x squared, 3x equals 70. I see that this is a quadratic equation because the x is squared. Quadratics, you need to get equal to 0. So the 70 needs to cross over. So it'll be 0 equals x squared, 3x minus 70. And then for a quadratic, you can use that formula. A lot of you all are just experts at plugging into the formula, so if you prefer to do that, you can. But most of these will solve by factoring unless otherwise noted. So we can factor that into x plus 10, x minus 7, and that's equal to 0 still. So the zero factor property says, this has been a big concept throughout the whole class, if you can get something in its factored form equal to 0, then each factor can then be set equal to 0. By the zero factor property, we're allowed then to set each part equal to 0 and solve, giving me the 2 solutions for the quadratic of negative 10 and 7. Now we're trying to find the width and the length, the dimensions of this box. So a negative 10 would not make sense back in the original problem, so that answer gets thrown out. So the reasonable answer is 7. So that was the width, right? 7 is the width. Now watch this closely, though. Okay, on this one it does say find the width if the volume is. So you have found the width. The width is 7. But sometimes it will say find the length, and you'll need to follow up. The length was x plus 3. The length would have been 10. So just make sure you answer the question that was asked. But we're good here. It did say find the width, which is 7. Okay, number 22. Number 22, it says we have 2 cars that leave an intersection. One is traveling north and the other is traveling east. So think of this as being the 2 cars taking off. One goes straight north, the other goes straight east, thus making this right triangle situation. And here's the distance between the cars. It tells us that when the car traveling north has gone 18 miles, that's just flat out given to you, no x involved, 18 miles. The distance between the cars, this distance is 6 more than the east distance. So this is your basic unknown, the east distance. The distance between them is 6 more than that. So what we're going to do then is plug this into the Pythagorean Theorem, which says side squared plus side squared equals the hypotenuse squared. Doesn't matter which one of these you write first, it needs to be equal to the hypotenuse, the side opposite the right angle. So 18 squared plus x squared equals x plus 6 squared. That gives us our equation to solve. And then we need to square everything out. So 18 squared is 324 plus x squared. Now be careful when you take x plus 6 squared. You either have to FOIL that out or use the pattern that says square the first, times together, double the middle, and square the last. Just make sure you do get a middle term when you square binomials. All right, it looks like it's going to be quadratic because I have x squared on each side, but notice if I would bring that over to the other side, the x squareds would cancel each other out. So that's just gone. So we actually have a linear equation left over, just x to the first power, so linear. So I throw the 36 across the line, or I minus 36 from each side. Let's see, 288 divided by 12, and 288 divided by 12. Somebody have that? 24, I believe. So x is 24. How far had the eastbound car traveled? So that is what we let be x. Again, this is important whenever you're taking the test. Make sure you answer the question that was asked. If it would have said how far are the cars apart, it would be that 24 plus 6. It would be 30 miles. But it did say find the east distance, which was just x. So x is 24 is the answer. Okay. All right, number 23. We have an equation with fractions. So I want you a lot of times students will tell me if I can get a problem started, I can finish it. It's just getting that first step rolling. So I want you to think about this. If you have an equation that you're trying to solve and it has a fraction in it, the first step to get you started is clear the fractions. It's really hard to know what to do with this mess of an equation while the fractions are in there. So the first step, no matter how big or small the denominators are, you've got to clean that up to be able to proceed. So how can I get rid of these denominators? You always times through by the LCD, the least common denominator, to clear those out. It's hard to tell what that is because this is not in factored form. So that factors into minus 8, minus 5 multiplies to be positive 40, but it also FOILs inner. Inner is negative 8x, outer is negative 5x, which is the negative 13x. So it does that reverse of the FOIL method. And it just so happens to be the same binomials you have here. So anyway, the LCD is one of every factor, at least one, and where it's at the most. So I need this, and I need this, and then they're just repeated here. So everything should fit into that. That is the LCD. So we times it by each side, x minus 8, x minus 5, multiplied by the left side, also multiplied by the right side. And then the magic of timesing through by the LCD is the fractions are just wiped out. So when you times it by the first term, the x minus 5's cancel. So you have x minus 8 times 3. Now I use it again on each term, so I just kind of lightly cancel it out. Because I want to repeat it here. This time the x minus 8's are diagonal. They cancel out, and I have x minus 5 times positive 7. Okay. Lastly, on this side, that's all just one fraction. So all of that exactly matches that, and it is diagonal, so it cancels out the fraction, just leaving the 5. So now we have this equivalent equation minus the fractions. And so now I feel like if you do that, you'd know what to do after that. You're real comfortable. We usually know distributing and combining. You do that so much, you can almost do it in your sleep probably at this point, right? So distribute, combine your x's is 10x. Negative 24 and negative 35 is negative 59. Plus the 59 makes 64. Divide by 10. 64 over 10, we can reduce that to 32 over 5. And we can see that is a choice. All right, any questions on that? Strategy for the test, I feel like, is know what you know well. You know, I feel like the devil is in the detail. I've told you with the final exam, any little details that you miss totally messes up your problem because it's multiple choice. So what you know, you want to know to perfection. So you look at this problem and say, I'm going to do this until I can do it in my sleep. I know this problem. And practice it. Find a sister problem to it in Math Excel and know it to perfection. It's probably better than going through every problem on the study guide and kind of knowing and saying, oh, I've seen that